My name is Reza,
Hi, my name is Jana,
and I will be explaining this component here.
and I will explain about how the machines we use.
Hello, my name is Reza, and I am going to explain the following electronic components. The components are fixed resistor, variable resistor, capacitor, diode, Zener diode, LED, and transistor. So, the fixed resistor. It is to reduce the flow of electricity in an electric circuit. It has certain value for each resistor. Now the variable resistor. To increase or decrease the amount of current in an electric circuit, the value of this variable resistor can be changed or controlled. Capacitor. Device used to store an electric charge, consisting of one or more pairs of conductors separated by an insulator. Diode. Diode is something which allow flow of current in one direction. The diodes are two types, reverse bias and forward bias. Now the Zener diode. Zener diode are a special kind of diode which permits current to flow in the forward direction. What makes them different from other diodes is the Zener diodes will always allow current to flow in the reverse direction when the voltage is above a certain value. This breakdown voltage is known as the Zener voltage. In a standard diode, the Zener voltage is high and the diode is permanently damaged if a reverse current above that value is allowed to pass through it. Zener diodes are designed in a way where the Zener voltage is a much lower value. There is a controlled breakdown which does not damage the diode when a reverse current above the Zener voltage passes through a Zener diode. Now the LED. The function of LED is to emit a light. Next, the transistor. So transistor. It is made of semiconductor material with 3 or more terminals used to connect an external circuit. This is called the transistor. So, thank you for listening my explanation about the components regarding the electronics.
Firstly is ampere meter or ammeter. It's used to measure electric current in a circuit. It's connected in series with device to measure its current, and it measures in ampere. Next is voltmeter, used for measuring electrical potential difference between 2 points in electrical circuit, connected in parallel with device to measure the voltage, and is measured in a voltage. Multimeter, electronic measuring instrument that combines several measurement functions in one unit. A typical multimeter can measure voltage, current, and resistance. Oscilloscope, electronic test instruments that allows observation of varying signal voltage, commonly used to display and analyze the waveform of electronic signal. Next is direct power supply. Direct power supply is unidirectional flow of electric current. A battery is a good example of direct current power supply. Direct current may flow in conductor, but can also flow in semiconductor and insulator. Alternating current power supply. Periodically reverse direction in contrast to direct current which flows only in one direction. Next is protoboard. Use a construction base in developing an electric current. It can be solderless, made of plastic and perforated with numerous holes. That's all.
Hello, I'm Chai Beng and we are doing the part B now. And from the procedure, it want us to sketch a schematic diagram first, and I had drawn it like this. And it want the 470 ohm resistor. So we want to find a resistor that is have this value, which is 470 ohm. And then we try to measure this value of the resistor. It is 463. So because it has plus minus error, so it's approximate to the 470 ohm resistor. And we move to the next step. It is the step 3. Adjust the DC power supply to 9 volt. 9 volt already. And now we set up the apparatus. So based on this diagram, you can see the resistor is set up at here, and the resistor is connected to the LED. So at here the long net of the LED is connected in one row to the resistor. So which means they are connected. And then another leg we just put on the anyway. And now the next step we put the diode inside. And the diode inside, you can see that the short leg of the LED is connected with the diode, the positive terminal of the diode. So you can see that here they are in a row, so means they are connected. And another leg of the diode, negative terminal of the diode, can put anywhere. And then we need to connect another leg of the diode connected to the resistor at this part. And we use the wire on the both grip ones. And we connect. Okay. Resistor and here. And now we put the power supply, this wire inside to complete the circuit. So the input one, the red color one, will be connected to the resistor, and the output, the negative terminal, will connected to the diode right here. Okay, so the LED is light up now. Okay, and why it will be light up? We based on this because the current flow like this, and positive negative, and it will be reverse bias and will be open circuit. So the will be like this, open circuit, and the LED will light up. And now we come to the step number 5. We want to measure the voltage across resistor and diode. And now voltage across resistor, direct voltage. Voltage across resistor. Okay, we can get the value about 6.8. Okay, and next the voltage across diode. If that is negative, so we change this one, and then we can get the value 2.2. Okay. Okay. Next, come to the step number 6. We reverse the direction of the diode. The LED not light up anymore. Why? Because we reverse the direction of the diode and become like this. And basically the voltage required by the LED is 1.5 volt and the voltage required by the diode is 0.7 or 0.2. So the current will choose the easier way. So the current will flow through this and not through this way anymore. So the LED will not light up anymore. That's it. I think I can explain this again. Because the current flow this way and the positive terminal at here and negative terminal at here, and it will be resolved to forward bias and cross circuit, and the LED does not light up. From this experiment, we conclude that the current flow this way and the positive terminal of the diode at here and negative terminal at here, and this will be resolved to reverse bias and will be open circuit and the LED will be light up. And the second case is current still flow like this way and the positive terminal at here and negative terminal at here, and we have reversed the direction of the diode and will be resolved to forward bias and will be cross circuit, and the LED does not light up anymore.
Hi everyone, my name is Andrew, and now I'll be explaining about Part C, which is AC circuit. After some discussion with the team, but theoretically, we conclude that the output waveform from the AC circuit will be a sine wave graph. Step 3.
For this function generator, function frequency we will be adjusting 1000 Hertz. Then for the amplitude, we will adjust to 10. Then we will save the value. For positive, negative to get the waveform.
This is how we connect the AC supply to the oscilloscope as output 1. Through oscilloscope, we obtain a sine wave graph.
Then we will be connecting the function generators wires and the oscilloscope wires to the circuit board.
This is how the AC supply connected with oscilloscope and the circuit that consists of SI diode and the resistor look like. Through the oscilloscope, we can obtain two different sine graphs by comparing output 1 and output 2. We can see that the graph only shows positive and it's slightly lower than the output 1 V peak.
Okay. The next step we will be measuring the VRMS across the resistor.
The average value of VDC, which is 1.275 volt, and this is the value of root mean square VRMS, which is 1.615 volt.
Yeah. Step number 6, we will be connected LED in series with the resistor. So from here, as you can see, we will connect the LED from here to the ground. So at the board, you can see that one of the leg is connected series with the LED. Then another one we will connect with the ground. Then it will light up.